when people think about pesticides, a lot of times they have concerns about pesticide impacts on the environment. So we're going to touch on some of those major issues right now. Pesticide drift, the movement of a pesticide from its intended application point to non-target sites. Surface water contamination with pesticide, groundwater contamination, and pesticide resistance development. Now, there are other issues having to do with pesticides in the environment, but these are 4 very important issues. Pesticide drift. The 2 most important factors when it comes to drift are wind speed and direction. Wind speeds less than 5 miles per hour are generally safe, particularly for handheld ground-based equipment. And in fact, wind speeds of 10 to 12 miles per hour might be appropriate, depending on the setting, what the surroundings are, the type of equipment that's being used, not just wind speed and wind direction as well. In fact, it may be valuable to have a little bit of wind blowing away from a sensitive site. For example, a 5-mile-an-hour breeze blowing away from a sensitive site is probably better than no wind at all. We need to talk about droplet size, because in addition to wind speed and direction, droplet size is the next most important factor when we're talking about drift. Now, whenever you spray a pesticide, you have a range of droplet sizes. Droplet size uniformity is probably not something that happens under most circumstances with most types of equipment. The small droplets obviously are the ones that are most driftable. So there's a relationship there between droplet size and drift. So unless you're a scientist, you're probably not familiar with the term micron. The micron is a way of measuring very small sizes. So droplet sizes less than 150 microns, they're the really driftable ones. They're the really tiny ones. Now, 100 or so, or 150 microns, that's about the diameter of a human hair. So we're talking about very small droplets. These are the ones that not only drift farther, they take longer to settle down onto targets. Now, when it comes to influencing droplet size, there are 2 things you've got to be concerned about. First one is lower tank pressures. The lower the tank pressure, the more larger droplets you're going to produce. If you ramp up, if you increase that tank pressure, you're going to produce more smaller droplets that are more driftable. In addition to tank pressure, also nozzle selection. So low tank pressures and select nozzles that produce larger, heavier droplets. You could also use drift control agents. Now, drift control agents are adjuvant chemicals. They're separate chemical products that you add to the tank to help the pesticide work better. In this case, by preventing drift, you're helping the pesticide work better. So that drift control agent, it generally works by making the pesticide water solution denser or heavier or more viscous. So you get heavier, larger droplets. When it comes to surface water protection, it is possible for pesticides to move into surface water. There are a number of different mechanisms that might cause this, but let's look at 2 very common examples. First off, this is from an agricultural environment, a farming environment. A lot of times agricultural pesticides, like insecticides or fungicides, are used during the winter on orchards or vineyards for dormant season pest control, maybe for diseases or insects. So applying a pesticide when there's a chance of rain, after you apply the pesticide when it rains, then maybe that pesticide gets washed off the target vegetation and onto the soil and moves into adjacent waterways. The second example would be landscape pest control. And this really doesn't have to do as much with weather as it does do with the relationship of when you spray and when you might use irrigation. So a very common scenario that might happen in a landscape setting is maybe during the summertime or the spring when there's actually no hint at all that it might rain. The pesticide application is made, maybe you're spraying turf grass or shrubbery, and you overspray onto pavement. And that pesticide is right there on the pavement. If you get the sprinklers coming on that evening after you spray the pesticide, it actually washes the pesticide across the hard surface into the gutters and into the waterways. Now, if the pesticide is toxic to aquatic organisms, like some of the synthetic pyrethroid insecticides, then you have a situation where you have both off-target movement of the pesticide, of a pesticide that's actually toxic to stuff that's in the water. So The take-home message on this is be careful about either rainfall or irrigation after a pesticide is applied. Groundwater protection. Now, pesticides can enter the groundwater via leaching or through openings in the soil. For example, if you have a heavily cracked clay soil or cracked wellheads, these are ways for the pesticide that's sprayed onto the ground to get down deep into the soil and get into the groundwater. Now, your choice between a clay soil or a loamy soil or a sandy soil, you know that sandy soils are going to be the soils that are at greatest risk for movement of the pesticide into the groundwater. So a pesticide's tendency to move into groundwater and to contaminate it is based on several different factors. First off, how water soluble that pesticide is. If it's a highly water soluble pesticide, then it's going to have more potential to leach into the groundwater. Additionally, if the pesticide has a low absorption capability for soil, it's not strongly attracted to the soil, right? If you combine that with a highly water-soluble pesticide, one that's not strongly attracted to the soil and is very water-soluble, that means that pesticide will be mobile in the soil profile. It's going to move, if you spray it onto the soil surface and you get a heavy rainfall or irrigation and it's a sandy soil, highly water-soluble pesticide that's not strongly attracted to the soil, it's going to move more readily into the groundwater. If you want to add on to that, a pesticide that's persistent, that doesn't break down quickly. A persistent pesticide, sandy soil, not strongly attracted to the soil, and water soluble, that's a recipe for that pesticide getting into the groundwater, or at least the potential for that to happen. Now, there are a lot of different pesticides that are used. And there's a lot of well sampling done in the state of California every year, going back many years, looking for different pesticides in water, in groundwater. But we don't see that many pesticides actually show up in groundwater. The ones that we do find tend to be herbicides, and they tend to be the pre-emergent type herbicides. Now, if you don't know, pre-emergent herbicides are the herbicides that you would apply basically to the soil surface with the expectation that the residues of that herbicide will hang around in the top couple inches of the soil for the entire season and kill new weed seedlings while they're under the ground. Now, the pre-emergent doesn't really kill the seed. It waits for the seed to germinate and then kills that new seedling while it's still under the ground. Well, these pre-emergent herbicides, they have all the factors that make them potential contaminants. They're usually pretty water-soluble. They're not strongly attracted to the soil. They have long soil half-lives. In other words, they're really persistent. And we're applying them right to the soil. So these are the kind of chemicals that you would expect to find in groundwater, and in fact, we have. Chemicals like atrazine or simazine or diuron, these are all pre-emergent type herbicides. The ways to avoid groundwater contamination of using pesticides is to follow the pesticide label. In addition to that, in California, DPR has delineated certain parts of the state as groundwater protection areas, where there are limitations of that pesticide use in that groundwater protection area. What you might have happening in this situation is pesticide resistance development. And let's talk about how that happens. Even before you spray the pesticide, even the first time, there's going to be some aphids in that population that already have a genetic resistance to that particular insecticide. And not just to the insecticide, to that insecticide's mode of action. Now, when we say mode of action, what that means is the way the pesticide works, right? So those aphids in that population, some of them, even before you sprayed the first time with that insecticide, they were already naturally resistant to that insecticide. So you can see then, if you think this out a little bit, that if you just keep using that same insecticide over and over again, all you're doing is killing the ones that are susceptible, and you're leaving the ones that are tolerant, you're leaving them to reproduce. Pretty soon, the only reproducing population are the tolerant ones. At that point, the insecticide's not likely to work very well at all. And that's how resistance develops. So the answer, the solution to resistance development is don't use the same insecticide with the same mode of action over and over again. Switch up, use different insecticides or different pesticide products with different modes of action. Now we've completed the session on environmental issues, so it's time to take a quiz.